Okay, so are you a person that has not learned ZBLL yet and you want to know how to have very fast last layer? So in this video, I'll be showing how you can predict PLL, well in this case G-Perm specifically, in certain OLL cases. So you'll see something like this in the stall that cancels into something and it looks very nice. So I'll be showing how you can do this. Okay, so in order for this to happen, the OLL has to meet two conditions. So the first condition is that right after the OLL, none of the edges move. So as you can see in this OLL, all these pieces are in place. So that means that right when the algorithm is done, none of the edges move. Same with the inverse. This case, none of the edges move once you're done. Same as this case, no edges move, so on and so forth. So that is the first condition. Okay, so the second condition is that the bar has to be on the left once you're done the OLL. So as you can see, the bar is solved on the left and the right side pieces are swapping. So some more here, here, here. So this is actually a lot easier if you know algorithms such as CLL or COLL, because you're able to look at the corner permutation and realize, oh, it's this one. So I know that the bar is going to be on the left. Because in certain cases, you'll notice that different corner permutations leads to different JOLL, like different bars. So for example, you have to do a U prime to get to this bar. But what you want is that there will be no pre-A left. So right when you're done the alg, bar on the left. Okay, so now that we have the two conditions of the OLLs out of the way, we can actually go to the G-Perm recognition. So as you can see in the G-Perm recognition, by looking at the edges only, you'll notice a few patterns. So for example, in this case, you'll see that there are diagonals here, and then these two are just random pieces. This is the same for every single G-Perm. So this case has diagonals here. Same as this one, diagonals here. Same as this one, diagonals here. And this helps you differentiate which G-Perm it is. So when it is this G-Perm with the diagonals in the left back, you know that the bar is going to be here. So this one, the bar is here. This one, the bar, it has to be here. And this one, the bar here. So there's kind of like a trend that the bar is actually a Y2 away from that diagonal pieces. Okay, so now as we remember the two conditions as previously mentioned, it has to follow this trend where none of the edges move once you're done and the bar is always on the left. So these cases match every single one of them, as you can see. So in this case, the diagonals are here. Which one does it correspond to? You have to just look. It is this one. So as we know, once you're done the algorithm, it will be this exact G-Perm. And you can actually just go into it right here. You can even cancel moves. So these two, out of the way. So this one, diagonals are over here. So which one does this correspond to? Nope. Oh, it's this one. So once you're done the algorithm, the G-Perm is going to be in the front. You can actually cancel into it. So you can go right into that. This case, diagonals are here. So which one can it be? Oops, I did the reverse order. But these two are diagonal. These two are diagonal. So once you're done the G-Perm, G-Perm is going to be in the front. Exact same edges. Diagonals in the front. Diagonals also in the front. So it's going to be this exact G-Perm with that in the back. That. You could do the U2, R2, F2. But I actually prefer to do this one where it cancels into the G-Perm. Okay, so you may think there's a problem that may arise. However, the reason I chose this case specifically is that it's very easy to demonstrate if there's going to be another case. So as we know, there are R-Perms, which also have the same edge swap, where these two switch in the back, and we're looking for diagonals, the exact same thing. So R-Perms are one thing, and J-Perms are another, where two are diagonal. However, you do not need to worry about this, as they are very obvious when there's an R-Perm or a J-Perm. Just look at this. You see so many blocks, and you already know, oh, this is going to be a J-Perm or it's going to be an R-Perm. Obviously, there's easy ZBLLs to do this, and that's why I chose these cases on purpose with the ones here, because it's very obvious to know, oh, this is a G-Perm because there's not many blocks. So let's do this one. J perm. This one, R perm. Oops, messed that up. Oh my. Jeez, okay. This one, R perm. This one, J perm. All right, I'm gonna be showing one more case that I really like, but obviously you can do other cases too, as this concept applies. For this case, as we know, it follows the two rules. Once you're done, the bar is on the left, and as we know from the algorithm, none of the pieces move. So let's follow it. So these two are the diagonals, and these two are the diagonals. So it's going to be this G perm. So go into that, cancel into that. Out of the way. This one is in front. Which one has the one in front? This one. So we know it's going to be this G perm. We can do a nice cancellation. This one. Right here in the back. Oh, not this one. Oops, just did that one. These two. So it's going to be this G perm. So we just go into that. And last but not least, this one. So we can just go into it, go into the back, like that.